Hello, everyone. Good evening. Dear authors and invited guests, welcome to Technical Session 3A. Myself, Ishita Sauryan, and I will be moderating this session. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP as the International Organization Technical Partner, Trinity University as the University Partner, Venomate DMC as a local organization MICE partner, and Springer Nature as publication partner, it is my great pleasure to welcome you all to the International Conference on Information and Communication Technology for Intelligent Systems, ICTIS 2024, Las Vegas, USA. The 8th edition of the conference is being organized in a hybrid mode. The physical event was organized in Las Vegas, USA on the 23rd of May 2024, and the virtual event is being held through Zoom today, that is the 24th May 2024. I hope you will all enjoy the knowledgeable and interactive sessions through the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for the presentation and 3 minutes for question and answer. On 10 minutes, we will be raising a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we get started, I would like to introduce you all to the chair for this session. We have with us Dr. Anna Trisolwick. Ma'am, Anna is a research scientist at Future Tech at MIT, USA. She has 10 years of experience in data engineering, data science, and open source software. Her research interests include measuring the economic impact of computing trends in technology, applications of graph neural networks in social sciences, high-dimensional research data sets and benchmarks, reproducibility and replicability of modern research methods. We welcome you, ma'am.
Thank you. It's great to be here.
Thank you, ma'am. I would like to introduce our next session chair. We have with us Dr. Meenakshi Sumitarya. Dr. Meenakshi Sumitarya is a director of AI research at Accrete.ai, an experienced academician with a demonstrated history of researching in the field of artificial intelligence and deep learning. She's skilled in machine learning, big data analytics, algorithms, data structures, and C++ programming languages. She's a strong education professional with a PhD focused in computer science and engineering. We welcome you, ma'am.
Thank you so much.
Thank you, ma'am. We will be beginning with the papers. I'd like to invite the first paper presenter for the session, Rich Moore, with the paper titled A Survey on Causal Representation Learning Techniques to Extract Causal Features for Causal Machine Learning Model Building. You may start with the presentation, sir. Sir Rich Moore.
All right. Thank you so much, Mr. Okay, let me share my screen.
Sure.
Let me know if you're seeing my screen.
Yes, sir, it is visible. Please go ahead.
Let me put on presenter view. Which one are you seeing? Is the presentation or the presenter view?
We can presentation, yeah. Go ahead.
Okay. Thank you so much. Rich Modzanza is my name, and I am a PhD research student at Cape Peninsula University of Technology here in South Africa. Good morning to everyone in the chat. I'm going to present on a topic, a survey on causal representation learning techniques to extract causal features for causal machine learning model building. I am going to look at causality, which is at the center for for one of the technologies that is actually growing, and specifically I'm looking at its marriage with machine learning, which will assist in addressing the fundamental problems and challenges that exist in traditional machine learning models. In other words, when I talk about traditional machine learning models, we are referring to the statistical association models, rather to move to causality. So challenges that exist in the traditional machine learning models, such as failure to determine cause to effect relationship between spurious correlation variables, accuracy, generalization, explainability, and robustness, continue to threaten their adoption and use in industry. Consequently, if you look at the estimation errors and generalizability problems in these models, in traditional machine learning models, can result in unfairness, bias, and even trust issues in these models, since they are being used in various industries, such as in the finance, to make very important decisions whether to, for example, to accept or deny someone to take a loan. Therefore, there is a need to conduct research in the marriage between causality and machine learning to address the fundamental problems and challenges that exist in traditional machine learning models. Hence, applying causal representation learning techniques to extract causal features for causal machine learning model building will help to minimize generalization error on unseen data, build robust and explainable machine learning models, improve machine learning model accuracy. These are the aim, research questions, and objectives. So the aim is to provide a comprehensive and structured analysis of the existing research on causal representation learning techniques for extracting causal features and compare them on their performance, strength, and limitations in building causal machine learning models with minimum generalization error on unseen data. Research questions, I've got 3 research questions with the corresponding 3 objectives. The first one being, what is the existing causal representation learning techniques used in feature extraction in structured data? So the objective there is to identify the existing causal representation learning techniques used in feature extraction in structured data. What are the strengths and limitations of existing causal representation learning techniques in causal machine learning model building? To determine the current challenges and limitations on existing causal representation learning techniques in causal machine learning model building. How does the identified causal representation learning techniques in the above research question 2 compare in performance on feature extraction? The objective is to compare the performance of the identified causal representation learning techniques on feature extraction. So a systematic literature review was actually carried following the PRISMA approach. And at the end, after applying various iterations and including exclusion criteria, looking at various databases, journal articles, at the end, the selected study ended up having 36 articles, journals, and research papers being used. And at the center of this systematic literature review, it was actually looking at causal, starting from causal learning techniques, splitting them into causal representation learning techniques and causal structure learning techniques. And under causal representation technique, which was mainly the objective or the research of this study, we actually looked at causal feature extraction techniques, which are listed below as Bayesian networks, structural equation modeling, causal inference networks or deep learning models, causal tree ensembles, invariant causal prediction, counterfactual reasoning methods. And from the study, this was actually concluded, we reviewed causal representation learning techniques of feature extraction and provided a comprehensive and structured analysis of the existing research on causal representation learning techniques for extracting causal features and compare them on their performance, strength, limitation, and in building causal machine learning models and with minimum generalization error on unseen data. The causal representation learning techniques, which were identified and compared on their performance, strength, and limitations, we actually see that these techniques, they have got actually advantages that they actually have if they are applied in building machine learning models, which help to solve the problem that most machine learning models have when they are applied in a different domain. So the problem like a generalization. So if we are to embrace or to actually apply these causal representation techniques in building machine learning models, we can solve those problems. But however, they've got also their limitations, such as counterfactual reasoning methods require strong assumptions. Estimating counterfactuals accurately can be also challenging. Also, they require domain knowledge, sometimes, which is a challenge to get an expert which with the domain knowledge or to integrate the understanding of how models are building. Complexity of ensembles can also lead to overfitting. So these are some of the challenges that actually were identified. Nevertheless, integrating of multiple causal representation learning techniques can be done to leverage on their respective strength and mitigate their limitations. So sometimes you can actually integrate the two or use two causal representation techniques together or to ensemble together, and they actually compensate on the weakness and strength of the other to get machine learning models that actually have got a higher generalization or minimum generalization error. A performance improvement in prediction tasks after employing causal representation techniques works as a testimony that the method is actually effective. Putting together causal reasoning, domain techniques, rules, and model inference will help to build causal machine learning models with improved generalization performance. A significant gap exists in developing causal reasoning, domain-specific rules, and model inference, which helps to build a causal machine learning models with improved generalization performance. So this study is one of the efforts to address the gap by systematically reviewing causal representation learning techniques to extract causal features for causal machine learning model building. This is crucial as machine learning models are now part of the modern solutioning in most systems, such as health systems, financial risk mitigation measure systems, education, etc. Which makes this a requirement, making requires them to be generalizable, which makes these machine learning models to be generalizable, explainable, robust, and accurate to promote fairness and trust. Thank you.
Presentation, Richmore. So I had just two questions regarding your presentation. The first one is that, was there some kind of a data set that you actually worked on when determining, like when doing this literature survey? Were you focusing on a specific domain, or is this a very generic research that you have undertaken?
So this one is a general survey that was actually taken. So I did not actually work on specific data. It's actually part of the next step that I'm going to take in the pipeline of the research that I'm doing.
So what kind of data are you intending to use, like the outcomes of this literature survey on?
Okay, so I'm actually intending to use observational data, history data on credit risk, and I try to apply these techniques to build a credit scoring model, which is able to generalize in different domains.
Okay, so have you like, I couldn't see specific machine learning algorithms that you have kind of looked at. So were there some specific algorithms that you looked at and the inference that you drove from them?
Okay, so the algorithms that I will actually look at is your Bayesian decision tree, actually ensemble them like your random forests, your group, and also deep learning models. Yeah.
Okay, thank you so much.
Yeah. Okay.
Thank you, sir. Ma'am Anna, would you like to ask any question?
Thank you. I don't have questions for now, so and this
Okay.
was a great presentation. Thank you.
Okay, we'll be proceeding with the next presenter. Thank you, sir. I'd like to invite paper presenter Ramadhir with the paper titled Adjusting Education Amid Emergency, a University of Technology Case. So you may start with your presentation. So Ramadhir, if you're here. Seems he is not available or is having some network issue. We'll be proceeding with our next presenter. I'd like to invite paper presenter Zevalos with the paper titled Exponential Smoothing Model Using Statistical Software to Forecast Peritoneal Dialysis Sessions. You may start with the presentation, sir. Yeah.
Yes, I'm going to share my print.
Yeah, sure, sir.
Oh. Okay, can see my print? Yes.
Yes, sir.
Really? Okay. Thank you. Good afternoon, ladies and gentlemen. This time I will present my research. I'm from Peru, and my team is from Peru. My research name is Exponential Smoothing Model using a statistical software to forecast peritoneal dialysis sessions. We are from Peru, and we would like to share with you the experience on this research. About 54.92% of most important hospital health managers talk that the shortage of human and material resources relate to more delicate procedures such as tomography, scans, and dialysis. What is more, it's important to know that only 10% of patients with end-stage renal receive peritoneal dialysis in Peru. This number is important, and we're worried about that number because health service or health subject is important in our country. So this is the first step to present the current situation. We are talking about an exponential smoothing model. This is a kind of forecast model, and that we use when the trend or the seasonality is high. So we don't have another forecast type like all winter or PMSA or machine learning. In this case, we're using this forecast model because the time series is to have a lot of variability of the data. We are talking about the session of peritoneal dialysis. This is the time series block. We can see this information is where it started on 2020 January. We can see this low numbers, low values, because COVID-19 pandemic. And this is the session in one of the most important hospitals in Peru. We can see a lot of variability of the data. We can see this is about a week we talk weeks, 1, 2, until 47, and we need to forecast a lot of the next times, the next data. This is the first plot, smoothing plot where we are working. We use a 95% PA. This is the value, the actual, the smoothed, and we have an forecast value that is here. Without the MAPE, that's 13.2. This is a good value. The math is good, and MSD in this case is good, correct? Because we can show that the session is like the value is like 1007. This is the forecast value that we can got. This is the PA for the value for October 2023. It's important to know, it's important to analyze the residual plot for the ICTIS, because this can make or view the atypical value in the data and the time series. We can see 1, 2 atypical value. That's for the year of COVID-19. This is the normal probability plot. Then the vertical fit plot shows the if this model is good or not, or we need to use another forecast type. In this time, we are using exponential smoothing with optimal ARIMA, because these values have a high variability of the information. We're not using another one. We don't have seasonality. We don't have a trend. So this is the Instagram value. This value and this analysis show that it's a good, but not a perfect model. But why we can answer the question? The importance of the COVID-19 year, 2020 year, have a typical level, a typical value in the data. We can show the observation, the versus order here. We can show this normal in this trend, in this time, but not here. Code that showing the typical. So we have two ways. Consider this data, the data of COVID-19, or not consider it. If we can't consider that, we can show a normal probability plot, a good probability plot, this optimal. The vertical fit show this aleatory information, aleatory data. This is a good model. This is optimal model, the histogram 2. The vertical order showed a good optimal value, but this is the second way. But we think it's important to take consider all the data, or we need to consider only the good values. This is important to make a decision. In the first way, we know that we can think in the future if we consider all the data, but if we don't consider it, we just making for a little forecast value for recently values. That's important to take to consider when we are making forecast model in health service. This is important. Finally, for the end, in this essay, we consider the time series, the accuracy measure that good may investigate good value. The experimental error in relation to the forecast for week 48 was 3.54%. Is a little value. And the residual analysis include the outlier due to COVID-19, good value. Similarly, when we are omitting this data, it will also predict optimal value. But we are explained what these two ways. And then the importance of this project is the low cost resource that it needs. This forecast model normally used for engineering, research, engineering subject, but we are talking, we are making, this is one of our first research to make health service, to make forecast this kind of model for the health service. That's important because we are not just take the important to make only engineering subject. We need to make engineering method in methodology in health service. This is important because we know COVID-19 hit a lot of people. Important dialysis, peritoneal dialysis is here in Peru. It's important. It's a problem at this time. It's important to make a tool to optimize this resource to have a good health service in our country. Thank you.
Thank you. I can ask one question.
Yes.
So my question is, what different models did you test for this? Have you tried multiple models, and which ones did you try, and how did they perform to solve this task?
Excuse me, could you write the question on the chat box? Excuse me. Okay. First, the first step to use or select a model, we need to make a time series analyze. In this case, we see the variability is high. We can use a seasonality like for winter or the composition method. ARIMA or SARIMA could be, in another research we used it, but an example with the simple mobile regressions could make not good values. So in this time we use exponential smoothing because the optimal ARIMA have the little accuracy measures like MIPA, MSD, and the experimental error was the little ones. So the only another forecast kind of model that we used was the simple, the mobile simple average. This is so many authors use it, but in this time we're just take the model that make the little or the lows accuracy measures. They make MSD. So that's the way that we use in this research exponential smooth.
Okay, thank you.
Thank you.
Thank you, sir. Ma'am Meenakshi, would you like to ask any question?
No, I think Anna already asked what I wanted to ask. Thank you.
Okay, thank you. Thank you, sir. We'll be proceeding with our next presenter. I'd
Thank
like
you.
to invite paper presenter Maravi Cardenas to present the paper titled Implementing the Lean Healthcare Model, a Knowledge and Change Management Approach to Reduce Waiting Times in the Healthcare Sector. You may start with the presentation, sir. So Maravi, if you're here.
Excuse me, yes, I can share you my screen, please.
Yeah, sure. Please go ahead.
Okay. You can see my screen.
Yes, sir. Your screen is visible. Please go ahead.
Okay. Good afternoon, everybody. My name is Alvaro Maraví, and today I will be presenting my research titled Implementing the Lean Healthcare Model and Knowledge and Change Management Approach to Reduce Waiting Times in the Healthcare Sector. Okay. About the study, okay, I have problem. Okay, sorry. Okay, I will continue. According to the abstract of this study, was conducted within a private healthcare facility experience challenging in its emergency department, where the efficiency of the process was recorded at approximately 39%. A proposal was made to introduce a lean healthcare model, emphasizing the pivotal roles of change management and knowledge management in its formulation. This comprehensive strategy successfully secured employee support for the envisaged changes, extremely like knowledge transfer during the implementation of lean tools. A result, a substantial maximum reduction of the 67% process waiting time was realized. The overall efficiency enhanced to 63%. Okay. Okay. In 2015, the World Health Organization highlight inadequate funding allocation in numerous countries for healthcare enhancements, resulting in diverse challenges and inefficiencies. Presently, the Americas stand third in terms of the percentage of the gross domestic product allocated to healthcare. However, several Latin American countries, such as Peru, still grave with budget limitation in healthcare compared to the global average, presenting notable sector challenges. According to the National Superintendence of Health, fine exceeding 6 million soles were imposed in 2016, with 69% attributed to private enterprises of the sector. Also underscores that delays in patient care are the most widespread issue in healthcare facility. Approximately 43%. The issue of the delay in emergency medical care extends beyond Peru, affecting numerous countries globally and underscores deficiencies in the process. The research aims to reduce costs associated with inefficiencies in emergency departments in the process by decreasing patients' waiting times. This approach utilized lean tools to identify and eliminate waits, reducing the care delays. Also, the effectively implementation of lean philosophy, a comprehensive exploration of available lean tools was conducted, resulting in the recommendation of specific ones. Chain management, knowledge management, bias, visual management, Kaizen, and standardized work. Okay. The contribution of the model. Like I mentioned, this study conduct research within a private healthcare center, focusing on challenges within the emergency department that to the process inefficiencies. To address this lean philosophy, tools were proposed to identify and mitigate process waste, aiming to enhance efficiency and reduce delays in emergency care. The selection of lean tools was based on their success in similar healthcare sector case studies. A significant challenge is a lean implementation project like in the change phase require work to adopt new activities and continuously transfer knowledge. This study suggests implementing a lean healthcare model tailored to the healthcare sector, emphasizing change management, knowledge management as essential pillars. The proposal aims to contribute to cost reduction resulting from inefficiencies in the emergency care process. in the figure number 1, in the slide, the pie depicts to the progressive development of chosen lean healthcare methodology, fostering a cycle of continuous improvement. Each phase involves knowledge transfers, and thus knowledge management plays a crucial role in efficiently generate and transforming information into knowledge. However, change management is national, ensuring participants understand the reason for the change and its benefits, fostering motivations and commitment to facilitate successful project implementation. According to the methodology, I show a flow chart. The first part we can see the phase 0 change management. Basically, I here analyze a problem assessment, then the implementation of the change management is everyday routines. The phase 1, the second phase, is bias training, elimination of unnecessary activities. No, in the next one is training on standardized work. Sorry, then take times to study. Recommendation system is the other one. No, creation of recommendation system. Here the workers propose new ideas. No, to improve the process. Then in the last part, the simulation and of discrete systems, creation of the simulation models, creation and modification of new procedures, assigning the Manchester trial system to the model, utilization reductions. Okay, I explain this better. For example, in this case, the validation, the case under review operates as a private healthcare company committed to delivering high quality services. Its goal is to establish itself as a leading private clinic in the service quality within the healthcare sector. The company offers various specialized areas such as general medicines, ophthalmology, and others. The research especially concentrate on the emergency department, which serves 3 primary patient category. Also, before diagnosis the emergency area, the process of the emergency department is defined for the investigation and improvement. It was discovered that the emergency department predominantly deals with the regular patients, suggesting a need for a more focused approach to this patient category. The research conducted on a clinic using a center healthcare using process and analysis tools such as value add analysis, uh, value stream mapping, work study, and others. Okay, according to the implementation methods, the validation process comprises a pilot phase and simulation. Pilot development involves phase 0 and 2, integrate knowledge management to support each tool and project implementation. Simulation was utilized data from time study and process flows for model designs, reaching phase 4. Change management to validate phase 0. The process begins with diagnosis current inefficiencies and their impact on the emergency area, and change resistance surveys measure initial project acceptance. Subsequently, the methodology conveyed the need for the change and address uncertainties. Implementation involved a comprehensive team comprising 3 doctors, 2 nurses, and 1 administrative staff. PIS and visual management initiative with training, clarifying objectives and goals, and audit revealed weakness, leading to improvements in organization and cleanliness. Visual management training reinforced 5S principles, utilize stickers for workstation organizations, standardized word training outline objectives and goals. According to the arrival times, patients were categorized in 3 intervals to account to the significance variance in arrival frequency. This JL3 distribution detailed in the table 2. Okay, the team study, a team study identified the distribution on each workstation, initially
Excuse me,
using
sir.
50 data points as example.
Excuse me,
However,
sir. I'm really
Yeah.
sorry to disturb you, but I'd like to remind you of the time limit.
okay, the conclusions.
Yeah, sure.
Okay, the results, the implementation model achieved a process efficiency of 68% with a standard deviation of approximately 5% and 3% of error, surpassing the spec efficiency of 55%. Thank you.
Thank you, sir. Ma'am, would you like to ask any question?
Yeah. So what performance metrics did you use for calculating or checking the efficacy of your models that you have developed?
Excuse me, can you write the question in the chat, please?
Yeah, I'm just asking, do you want me to write it? I just wanted to know
Yeah.
what performance metrics have you used? Okay, sure.
Okay, please. Okay, according to the questions, the indicator that I used to the model was the cycle, the time of all the cycle in the process of the emergency department, and the waiting times is the two indicators that show me the situation of the emergency department. For example, when we start the study, these metrics don't have a good numbers. For example, the result of these indicators don't get the goal, and them of apply the methodology of clinical care, we can reduce the waiting times and the cycle process, no? And in this case, the cycle process in minutes, no? Is the value of the indicators. We can reduce this time, no? And in other, according to other research, each indicator, the cycle time is called like is known like efficiency of the process is other name of the indicator.
Thank you so very much. Thank you.
No questions from me, so we can proceed.
Thank you, ma'am. Thank you, sir. We'll be proceeding with our next paper presenter. I'd like to invite paper presenter Ramadil with the paper titled Adjusting Education Amid Emergency, a University of Technology Case. So you may start with the presentation.
Let me share my screen.
Sure, sir.
Is it visible? Yeah?
Yes, sir, it is visible. Please go ahead.
Okay. Okay, thank you, Chair, once more, and colleagues. I'll be presenting a paper titled Adjusting Education Amid Emergency, the University of Technology Case. Now, this presentation is divided into the following sections: introduction, research methodology, result and discussion, conclusion, lastly, reference list. Now, with introduction, COVID-19 pandemic caused extraordinary difficulties for ensuring educational access on a wide scale, with educational institutions shut to curb the spread of the virus. Customary face-to-face learning became illogical. Now, during this time, materials for instruction that were necessary for practice, such as laboratories, became outdated. Teaching strategies that relied heavily on human interaction and required direct contact with students were severely impacted. Some practice-based materials were just not feasible. Now, accordingly, e-learning arose as a practical choice to guarantee schooling progression. The education sector has long recognized the effectiveness of electronic learning. Evidence of the challenges involved in putting into practice keeps growing. Now, to minimize the effects of the pandemic on education, numerous governments have initiated crisis response throughout the world. Now, this protection encompasses curriculum adjustment, accessibility of infrastructure, and technology resources, for example, gradually until physical instruction became permitted. Universities were expected to address this distinction through various means, for instance, giving workstations and web access and offering flexibility in assessment. Now, methodology for study. Now, this was a qualitative case study design, and the participants of the study comprised of undergraduate student from University of Technology in Gauteng province. The data gathering tool, purposeful sampling based on their access to the internet, having computer devices, and being in online and learning during the height of COVID-19 was used to select the participants. And the total of 16 participants were involved in this study. And data gathering tool was semi-structured interviews that were administered online via Microsoft Teams meeting from February 2021 to April 2021, from students whose ages range from 18 to 25. And COVID regulations stipulated by the government were also enforced during this study. Analysis was done using qualitative content analysis, and content analysis was assisted by ICTIS TI software that is used for qualitative data analysis. Now, the procedure for gathering the data, participants were invited to participate through their institutional email accounts. Consent forms were also sent out during the invitations. Now, the only participants would email back to the researcher with completed consent forms. And data gathering was also administered online using Microsoft Teams meeting. And the researcher called on consent participants to schedule interview sessions. And there was also a provision for participants basic training on Microsoft Teams. Fortunately, all participants had previous experience with Microsoft Teams tool. And interviews were recorded with participant consent for data analysis purposes. Now, results and discussions. The following things were generated: technological challenges, socio-economic issues, instruction challenges, and load shedding. Now, under technological challenges, one participant stated that stable internet connection was my major challenge. And the other participant replied by saying, my computer was very slow and could not afford to install some of the important programs needed. Second theme, socioeconomic issues. Some of the participants were quoted as saying, I was so solely relying on free Wi-Fi provided by the university. My parents had to take a loan to purchase a laptop. And other participant replied by saying, relative had to cover my data costs as my family was unable due to retrenchments because of COVID-19. Now, under instructional challenges, participants also quoted as saying it was difficult to consult with lecturers on one-on-one. Often lecturers would respond late to our emails, while second participant stated that it was difficult to discuss the material with peers. Other peers that would deplete during the discussion. Now, lastly, this load shedding. Now, under load shedding, one participant was quoted saying, "I was frustrated to get the recordings of the lecturers in the event I missed online class due to load shedding." Now, the discussions from the findings or the result of the study are the following. The lessons learned from the findings are that e-learning is both challenging and rewarding. And also, e-learning shows promise in leading educational endeavors of the future. Now, to see this happening, equal usage, access, and acquisition should be prioritized. Students who experience challenges with e-learning were those with connectivity, data, and equipment issues, whether it was a laptop or a personal computer. Also, one major matter that was identified is that e-learning is welcomed by students from high-income families. They have no struggle with data, connectivity, and equipment. And conclusion, COVID-19 pandemic strained educational instruction and forced educators to embrace e-learning as a fundamental device to guarantee instructive its capability to cultivate opportunities for development, adaptability, and commitment to teaching and learning. The examples gained from this experience will shape the fate of education, underscoring the requirements for an innovation mix, impartial access, and continuous educator support. These are some of the reference list, and I will also finally I would like to thank you, colleagues and chair, for your time, and I also provided an email in case that more info or collaboration with regards to this study is needed. Chair, I was talking about my PC shows that I have unstable internet connectivity, but I've yes, I was about to finish, but now I got a message to say that my internet connectivity is unstable. I don't know why. Hello, Chair.
Ma'am, would you like to ask any question?
Yes, I'm listening. Chair. I'm listening. No problem.
Yeah, so I just have one question, like post-COVID, what is the application? Like how much is the applicability of what you proposed just now, now that we are not in the COVID era and everything has moved back to normal? So how much would this be relevant today after your research, which would have started a couple of years back?
Okay. Okay. I'm not sure whether I heard your question correctly, but to answer, I would say the data was gathered a long time ago, while most of us were sitting idling at home, nothing to do. Then I had to gather data. But moreover, on that, I feel like since we had an experience with this e-learning, we shouldn't ignore it. We should continue. For example, at my institution, we are using in fact, we have physical and online sessions. Most of the subjects are now, especially ICT subjects, are now online, are now conducted online. While those with practicals, for example, like chemistry, students had to come to physical contact. Now, say we shouldn't totally move back to physical like we used to do prior COVID. We must also embrace this mode of e-learning. Because with e-learning, yes, I'm listening, Chair.
Yeah, that answers. Thank you so much. Thanks.
Thank you, sir. Thank you, ma'am. We'll be proceeding with our next paper presenter. I'd like to invite paper presenter J.E. Ifeon to present the paper titled Towards a Bio-Inspired Real-Time Intrusion Detection in the Smart Grid. You may start with the presentation, sir. So if you're here, then you may start with your presentation. Seems he is having some issues. We'll be proceeding with our next paper presenter. I'd like to invite paper presenter Ali Reza Hashemi to present the paper titled Visiting Distant Neighbors in Graph Convolutional Networks. You may start with your presentation, sir.
Hello everyone, this is Ali Reza Hashemi, and sorry for not being able to present online and live in this conference. But yeah, here is my research project, which is my submission to the ICTIS 2024, and it's on a new method on extending the graph neural networks, a specific type graph convolutional networks, and we're gonna have an expansion on that original vanilla graph convolutional networks. So in general, graph neural networks are deep learning models to tackle problems where data is structured as a graph. So you have some nodes, some way to connect these nodes, and you want to make a prediction on either the classification for graph, classification for nodes, for edges, community detection, and many other use cases like link prediction and even graph generation. So convolutional neural networks are generally introduced in graph convolutional networks are generally introduced in 2070 on this paper, which was published on ICLR by Thomas Keefe and Max Welling, semi-supervised classification with graph convolutional networks. They introduced this paradigm of graph convolution as basically this underlying formula. So what you do on each step is you aggregate the node features from the neighbors into the node. So each node will receive from its neighbors in this way. So I'm going to go through this equation one by one. A is the adjacency matrix here, which we add self loops in order to keep the information of the node in each step of the convolution. So here D is the degree matrix plus the self loops we added. So it is a diagonal matrix, and on each element it's going to have the degree of that node. This is to kind of normalize for the effect of high degree versus low degree nodes, so we won't be separating them. H is the previous layer node embeddings, which so in the first layer it's going to be just the node features as it is mentioned here. W is the trainable weight matrix, which we are going to train on each layer, and sigma is just any nonlinear activation function. So in this way we will get the node features on each step from the previous step and originally from the node features. So for example, a really famous example for convolutional networks in graphs will be if we take a look at the network of citations in academia. So for example, if each node is a paper and edges mean citations, then the task would be to classify the paper into classes of physics, computer science, biology, things like that, based on the node feature, which is the title of the paper, and the connections, which are the citations. So this is a pretty standard problem and benchmark for neural networks in graphs. So what we are going to add to this problem is a higher order neighbor aggregation, in which we will add the features from neighbors of the neighbors and neighbors of the neighbors of the neighbors, and so on and so on. So this here is the general formula for our higher order convolution, but this is in the case where you want to stop this expansion at second neighbors. So what this equation means is you'll have a trainable parameter gamma 0 for the importance of the node feature itself, gamma 1 for the importance of the immediate neighbors, and gamma 2 for the importance of the neighbors of the neighbors. So this convolution is adding this part where we can, the model can, if it wants, because it's a trainable parameter, get information from further away neighbors. And H0 is just the original node features, and W is the trainable matrix. So here, just for comparison, we have three models. The first one is just the vanilla convolutional in graphs, and the second one is the expanded graph convolution up to the second neighborhood, with the third one being up to third neighborhood. So this element would be the node feature itself, the self loops. This element will be the immediate neighbors, and this element neighbors of the neighbors, and the last one neighbors of the neighbors of the neighbors. And all of them have like trainable parameters, so the model might end up setting these to 0 and not paying any attention to them. So it's basically can be the vanilla graph convolutional network if the model decides so. So we're gonna benchmark on 3 different data sets. As I mentioned, they are all citation data sets. They are pretty much the benchmark for evaluating any graph convolutional or any graph neural network. They have like thousands of nodes and thousands of edges, and each one has different number of classes and features. So for example, going through the first one, 3,000 nodes, 4,000 edges, and you want to classify each paper, which is a node in this dataset, into 6 classes using the node features of 3,000 dimensional. So here are the results comparing our method up to third neighborhood, up to 2 neighborhood versus the vanilla graph convolution. So looking at the last one, this is a semi-supervised classification. So we are gonna provide the model with a number of training examples and ask the model to classify the rest of the examples. So when we provide the model with like 20 training examples, like as in this last row, they all pretty much perform the same on each of these data sets is almost within the range of the error range. But when you decrease the number of training samples, the expanded versions really shine. So for example, given only 1 training example, because the expanded convolutions are aggregating data from further away neighbors, they can perform up to 10% better than the vanilla version. They also learn much faster in terms of epochs. So this is the learning curves, training accuracy, validation accuracy versus the number of epochs. As you can see, the higher order graph convolutions can learn much faster. But of course, this comes with a computational cost, and we are aware of that, which is the problem of finding the neighbors of the neighbors, and so on and so on. because this is going to be a computationally heavy task. So the more edges you have, the larger your network is, the more price you're going to pay for this dimensioned increase in accuracy and increase in the number of epochs. So this is kind of a trade-off. If you have a huge network, then you're gonna spend so much time finding the higher order neighbors in order to be able to train this model, and but you'll gain in terms of accuracy, in terms of lower number of training samples needed, and also in terms of the speed of learning in epochs. And yeah, that's it. That's our expansion for graph convolutional neural networks, and thank you for listening. Hope to hear from your other presentations in this conference. See you soon. Bye.
Ma'am, it was because of a technical issue that we had to present the recorded video, the paper presenters, and they're not here because of some technical glitch. So we'll be proceeding with the last presentation for the session. I'd like to invite once again ask for J.E. Ifyong. If you're here, then you may start with the presentation, sir.
All right, please, let me share my screen.
Sure, sir.
Is it all right now, please?
Yes,
it
it is visible. Please go ahead.
Okay, good evening, everyone, participants at the conference. I'm sorry for the technical glitches I've had initially. My name is John Ifyong, and I'll be presenting a paper on towards a bio-inspired intuition, bio-inspired real-time intuition detection model in the smart grid. This paper was written by myself, John Ifyong, Temitope Ajayi, Abiodun Akinwale, and the rest of us. So, can you still see my screen?
Yes, sir.
Okay. This paper, this is the outline that we use to talk to the full introduction, reviews, and the rest of it. This paper actually centers around the smart grid environment. The smart grid environment is an environment of interest because of the services that are provided from the smart grid. And it has been characterized by integration of advanced technologies like the use of sensors, the use of IoT devices to make power provision and utilization more efficient. But it's why it has become a center of interest for attackers to actually get interested. So there is a rapid growing dependence on interconnected systems such as wireless sensor networks and the rest of them, which I've said earlier. Because of the massive benefits that come from the utilization of the smart devices for the smart grid, it has become a sweet point for attackers who want to exploit the devices that are used in the smart grid. Efforts have been made in literature to see how to improve the intrusion detection systems that are used in smart grid networks, but they have challenges such as high false positive, and particularly that of not paying attention to the real-time intrusion detection in the smart grid. So there is a current move to utilize bioinspiration for improving the efficiency, improving accuracy, improving the metrics that are used in evaluating systems that are built for intrusion detection in the smart grid. So that is where bioinspiration comes in. Because biological systems offer inspirations that can be used to solve computational problems. And in computing, there are several algorithms that come from biology that have been used, such as the genetic algorithms, swarm intelligence, artificial immune systems, and the rest of them. For this paper, interest was on the use of artificial immune systems to see how the human immune system is able to detect intrusion, external intrusions into the body, and then fight the intrusions, and then recover from whatever damages but that will have cost the system. So we drew inspiration from biology to see how to model intrusion detection problem in the smart grid. So I will just move down because of time let me just move down and leave some slides. All right, we've reviewed a number of literature that have attempted to solve the problem. Now, only a few of the literature we've reviewed have made effort to utilize nature-inspired concepts to develop mathematical models, but they have not really taken time to explore the possibility of using these systems to build real-time intrusion detection systems. And that is where our system comes into play. Now, from the work of Pinto et al. 2022, this is a model that they proposed, which is actually a biological system that tries to draw inspiration to see how to solve intrusion detection problems. Here, their system did not take notes of how to ensure real-time intrusion detection in the smart grid. So what we've done here is to see how to enhance the architecture they proposed by including more modules to the architecture and then making it into multi-layers, typically 3 layers, so that the data that get into the network go through the 3 layers for intrusion to be detected before it begins to harm the network. So the concept of the dendritic cells algorithm is actually derived from the artificial immune system, which emulates how dendritic cells move around the body to collect antigens and then provide antigens to fight, provide antibodies to fight antigens in the body. So in this study, we are fusing the concept of the dendritic cells algorithm with machine learning algorithms and deep learning algorithms. At the same time, we have deployed what we call the zero trust architecture to see that there is no level of trust given to any device on a network. So this is the multi-layered architecture that we have proposed, which has 3 layers. Each layer is expected to provide a level of intelligence where a layer is not able to detect threats, it moves to the next layer. And it is expected that before a threat goes through the 3 layers, it will have been detected on a network. So the data set we use for training our model is a data set from a testbed that is available at the Cyberscaler lab at Obafemi Awolowo University in Nigeria. And this data set has over 2 million samples with 12 attack patterns and 16 features. For the techniques we used, for the first layer, layer 1, 2 machine learning classifiers were used, random forest and XGBoost. And then at layer 2, 2 deep learning algorithms were used, and layer 3, 3 deep learning algorithms were used for intrusion detection. There are a number of metrics, performance evaluation metrics, which we use to evaluate the performance of the system. But the most important of them was the latency, which we use. Please, can you see my screen? Yes, I stop here. A number of metrics, performance evaluation metrics were used, but the most important of them was latency, because we wanted to see if the model we've developed is able to or will be able to detect threats in real time. So latency was used. A number of latency options were used, which we eventually added to give us a sum of the latency used in evaluating our model. Please, next slide. Admin, please, next slide. For the results of the performance evaluation. At the first layer, a random forest yielded a latency of 0.00 milliseconds, while the XGBoost had a slightly higher latency. At layer 2, the gated relay units obtained a latency of 0.013 milliseconds, while the partner, the DPN, yielded 0.00. Then for layer 3, the recurrent neural network had a latency of 0.0033, DNN 0.001156, and LSTM 0.0127 milliseconds at the last layer. Please move to the next slide. This is summarizing the table 1 here, how each of the layers and the algorithms in their performance. Now, the zero latency found reported by Random Forest actually suggests that this algorithm can make predictions exceedingly quick, which is an excellent algorithm that can be used for real-time intrusion detection problem. The XG Boost had a moderately low latency, which also suggests that it can be used for real-time intrusion detection efficiently. Next slide, please. Yeah, this also reports the performances of each of those algorithms that were used and how they stand in intrusion detection in real-time situation, as the case may be. DBN, Random Forest, they showed outstanding results with low latency of 0 millisecond, which make them outstanding for intrusion detection in real-time scenario. Please move to the next slide. These are plots, the latency plots that show the performances of each of those algorithms as used. Some have flat line, like the ones that actually have latency of 0 can see a straight line, straight horizontal line. Others have spikes at some points, showing that the data points actually showed that they could actually not do very well for real-time intrusion detection. That's what it's saying. Thank you. Please, next slide. Yeah, for other metrics were used, like I said before, other classifiers, other metrics were used like accuracy, precision, recall, F1 score, and other cost metrics were used to evaluate the performance of the classifier, especially those ones at layer 3. We can see that each of those 3 algorithms did very well in terms of accuracy, in fact, in all the metrics. And then we can also see how they performed in with false alarm rate and based alarm rate, showing that DNN is very good when it comes to layer 3 detection for real-time scenario. Please, next slide. Next slide, please. Yes, conclusion. In the context of intrusion detection, we understand that in cybersecurity, having a very low latency is important for real-time intrusion detection. And that is why the choice of Random Forest, GBN, and the rest of them that have shown very low latency is crucial when modeling intrusion detection problem. The result have actually demonstrated that this model can help in real-time intrusion detection system, intrusion modeling in the smart grid, which is the focus of this paper. Thank you for listening.
Thank you, sir. Ma'am, would you like to ask any questions?
Yes, please, I'm available.
Don't have any questions?
Ma'am Meenakshi, would you like to ask any question? Okay. Thank you, sir. That brings us to the end of the session. I'd sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 8th version and the previous 7th versions of the conference held in Asia. We will be happy to have you in 9th version in 2025. All the presenters will be getting their digital certificates through email within 2 working days. Further all the papers have been already forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICTIS 2024. I'd also like to thank our session chair, Dr. Anna Trisovic, for chairing the session, a token of appreciation to the chair on behalf of Team ICTIS 2024 and the organizing partners. Thank you for your valuable presence, ma'am.
Thank you so much. It was wonderful to be here. And thank you to all the speakers and the organizers.
Thank you, ma'am. I'd also like to thank our session chair, Professor Meenakshi Sumit Arya, for chairing the session, a token of appreciation to the chair on behalf of Team ICTIS 2024 and the organizing partners. Thank you for your valuable presence, ma'am.
Thank you so much. I had fun, and congratulations to all the presenters for wonderful presentation. Thank you.
Thank you, ma'am. I kindly request everyone to switch on the cameras for a quick snapshot of the virtual conference. Thank you, everyone. Stay safe and take care.